Here we go. Without further ado, here we go, John. Thank you.
Thank you, Luciano. Yeah, I mean, this is the second security talk, right? So I was trying to make it brief and make it interesting. Actually, I have to say that Patrick has done a great job this morning, and he already laid down the groundwork and many issues about security that we have to face. Actually, I'm glad to announce, beforehand that actually OpenFog is doing what he asked us to do, so we're on the right track. Okay. Just on the same line. Okay. People wanted to know who I am. I'm the John Z in the OpenFog because the security working group is now kind of organized at the two. We always call us John and John, right? So John Fly from ARM and me, John Zhao from NCTU, which is actually a university in Taiwan. It's affiliated with Shanghai Jiao Tong University. So I'm in Taiwan right now. But anyways, I'm the co-chair. Luckily, get elected just a month ago, and working with John and working with Rob and working with a lot of people here. My background, I was actually not exactly like an academician. Even though I got a PhD from Harvard and all those things, I was actually a BBNer. I worked at BBN right after I graduated from Harvard, and lucky enough to have a chance to work with Steve Ken. I think some of you know him. He started the IPsec protocol and also started the PKI infrastructure, et cetera. So I learned a lot from him in the 10 years I was with BBN. And then go to Taiwan because my wife is a Taiwanese, and recently it's just formed two companies. They are affiliated. One is called Ango in San Diego. The other one is called Cerebatech in Taiwan. It's not about security. It's about EEG, okay? But we use fog computing and machine learning to do our thing, and that's how I get involved in fog, and also get introduced by Tao of Cisco and start my involved in early March, and now here I am. The thing that I want to talk about, just you can say it's a continuation of what Patrick has talked about this morning, but we want to put an emphasis on what OpenFog, we are working on, what the approach that we're trying to take. We are still far from completing, but we at least now start to find our way through. The first thing, of course, we'll say that security is really important, and we just get a free advertisement. When I was on the plane, and these days you get internet on the plane and read the news and say, "Holy God!" On Friday, October 21st, Eastern Standard Time in U.S., Eastern Daylight Time still, in U.S., there's a huge DDoS attack on the DYN, the DYN. This is the global DNS service provider, that actually bring down DNY. And as a result, it affects Twitter, Reddit, GitHub, Spotty, even affected PayPal, New York Times, BBC. I read this news from BBC, and BBC admitted that they get affected. They all get affected because one important service, the DYN, was brought down. And it was brought down by IoT devices, actually brought down by closed service security monitoring TV, CCTV, cameras, and net printers. Now, the amazing thing is the scale. They actually use more than 10 million devices across the internet. They just basically create a botnet using the malware called, how to pronounce it, Mirai, Mirai. They use that to create a botnet consists of more than 10 million devices and attack the DNY and then brought down the DNY, and as a result affected everybody. The trick is simple. I mean, you cannot believe it, just because most of these internet devices, they have factory default user ID and password, and many of them you cannot change. So you basically use one user ID and device, you can get 100,000 devices. So it's very, very easy for you to bring down the whole system, if you have these kind of things. So what can you do? These are real IoT devices, and this is happening. And I don't think this is the isolated incident. Actually, this is a follow-up of a payload attack before, right? And will happen again and again. So the issue is IoT security protection is, we need it now, okay? And how do we do it? Okay, so that's the concern, okay? And also, of course, there's another concern that I'm trying to talk to a lot of people about here, is how do we make IoT and fog, if we want to put fog really into the field, deploy in the field, how to make them interoperate. And also, there's another thing that, inside our security working group, we are always, considering, how do we actually make our fog itself actually secure? Because actually, let's say it, IoT plus fog is a new architecture. I think Jeff has mentioned it, it's pervasive. It's actually even multi-tier. It's a good news, but to security, it's a bad news. We really have, a new architecture that we haven't, that was before. We haven't put, if in the future we deploy this, we haven't put that many, servers that are connected to each other, and also highly connected to a lot of tenants. Anybody that kind of trying to log on it and use our server, we'll provide service to them. And this can affect a lot of things, if we don't do it carefully. So it's a lot of concern. So let me just use this slide to give you some of the things that we are doing. So in OpenFog working group, the three working groups are working together: the security working group, communication working group, and the software infrastructure working group. We are now actually, Bob has asked us, and we really committed to really sit down and talk and think about what is a common structure, a common layer that we have to put into our reference architecture that particularly address interoperability problem and security problems. So basically secure interoperability end to end. And to that, we actually think about two things that we like to do. So this is kind of like a heads up of what we are doing. We do not promise that we can deliver that anytime soon, but at least that's the approach. And please give us your opinion about whether this is feasible, your concern, and even your suggestions. One of the things that the first thing we wanted to do is to kind of create the core service. We want to just, basically an API, but we don't want to create the API. I won't call it the minimalist API. What is the core set of services? What is the core API or interface that we need to put together, allowing the IoT device to talk to the fog and other fog to talk to the other fog node and to the cloud. Okay, and Brad has been leading this effort. Brad from RTI, I think he's down in the on the floor now. His basic suggestion we would have two layers. We would establish a service layer, we establish a support layer. Now this is not only about security, this is about actually basically information transport and application pathway. So service and support. We are thinking about building, that's his term, I like it very much, a software backplane that can stretch across different fog nodes and link it to the things that we want to talk about. And then put in finally the monitoring and management mechanism. So these are the three aspects of this thing. We have two layers. We have a backplane, there's an API. And then we have the service, the management and monitoring services. That's the idea. And another thing we are talking about is also an operation scenario. We call it collaborative security practice. That service scenario, you can say, divided into two prongs. One is actually, hopefully, we give you a secure offload. What it means is, if you feel that some of the IoT device, they are non-secure, get their data or something uploaded to what you believe you trusted as the trusted fog node, and put it there, or migrate it from the fog node gradually to the data center that you want to put in. So basically, the fog node itself would be, the IoT device itself would basically be just a sensor. No tricky, sensitive information will be stored there on a long run, okay? Computing also, dedicated critical computing will be done in a trusted fog node, not on your service, on your sensor. Not only does, kind of release the burden, but also hopefully increase the security. Another thing that is first proposed by Tao, and think we are now catching on, is called security as a service. We always think that fog itself needs to be secure, and how to make ourselves secure. We never look at it the other way around. If fog is indeed, relatively secure, at least then the IoT device, can we export security as a service to the IoT device? They may not be able to defend themselves. Most important, they may not be able to monitor themselves. They may not be able to react in terms of crisis. Can we do them on their behalf? So this is the term that we kind of invented and put it down, SEC as a service, SECaaS, so to see whether we can do that. So this first slide is almost like a highlight of what we are going to talk about. In our working group, we are kind of taking a optimistic view. We always think that challenge and security are two sides of the same coin. If we solve them or overcome some of the challenges, we create opportunities. So the challenges, we are writing a set of minimal requirements that we have to meet in order to, to kind of deliver our things. I have to say that we haven't converged yet. We are writing that kind of requirement. Actually, sorry, Rob, we did it kind of like backward. We wrote a lot of things, and now we go back to write the requirements, right? But anyways, it's a start. But at least finally, we kind of get this high-level thing. We say that we are building a heterogeneous IoT and OpenFog system, right? It's a pervasive multi-tier platform, right? What we expect it to do is that it have to be secure enough so that the user would entrust their application or business on it. Now, this is a very loose thing, but nonetheless, this is very true. We are not promising absolute security, but we are promising enough security for different applications. Maybe they have different watermarks, so that they would feel that that's safe enough for them to entrust their application or business and use our fog node. And that's our goal. And then the two services, as I mentioned, trying to make ourselves secure enough that people would actually put their process running on us, put their data, store it in us, but then also see whether we can export security to make the IoT device more secure. Okay, what are the issues? That's the challenges. The major challenge actually we find, it's all related to these abilities, interoperabilities, incrementability, scalability, mobility. But among all these four abilities, I think the interoperability poses a lot of problems, the major problem. The question is, if we want to make our thing to really interoperate, not only with one another, but also with the things, what are the things that we have to interoperate, and what are the minimum requirements we would expect from them? Now, currently, I'm jumping forward a little bit, we are thinking that we at least require them to be, since they say IoT, they speak the IP protocol stack, the TCP IP UDP protocol stack, or be able to adapt to the IP protocol stack so that we can communicate with them. But I know that from the industrial people, that is just the bare minimum requirement, because the QoS is another concern, right? If we do that, but we ruin your QoS requirement, that's not good enough, right? So we have to think. There's all those diversity that causes to be a trouble. There's another issue that also will cause us trouble in terms of timing and QoS, is that there seems to be two kind of paradigm that's going on. One is the traditional client service paradigm, but there's an emerging publish-subscribe paradigm based on event-based, out of event-based computing, that people are now talking about publish-subscribe, and how does that affect our implementation and our requirement? We don't know yet, but we will look into. The other abilities, incrementability, scalability, mobility, we actually list out these four things, but I think we will only tackle some of them. There's a thought, we have one version of fog. There's no one version of cloud. They have open cloud, private cloud, hybrid cloud. We are going to have something like that maybe in the future, but then if that's the case, the security requirement is maybe different. Brad and I are working on so-called defining this different, temporarily we call different kind of scenarios, okay? We have probably the bronze level, the silver level, the gold level cloud, or what we call the embedded, the standalone, the clustered fog. We have to think about that, okay? People have actually asked us whether they can on-demand deploy fog nodes, plug and play IoT devices. If I room near you and I get a Wi-Fi or whatever connection with you, can I simply just start using you? Those are the things that create a lot of very dynamic issues that we don't know how to overcome totally yet. But at least we lay out the so-called functional parts, okay? The whole OpenFog security is now divided into two parts. One is the end-to-end security. You can think of this as our data plane, but data plane plus a little bit of the basic control plane. And the other part is really the security management and monitoring part. We separate into two parts. And underlying the end-to-end security part, we divide into, as Patrick has alleged, the data security, but then as OpenFog, we take the fog-centric approach. So the first thing we tackle is actually node security. And we are glad to report that that one has been mostly done or been relatively mature. And now we are working on the network security part, trying to get the protocols and things there. And then finally talk about security, the data security part, data in use, data in storage, data in transit. Data in transit will be folded into the security, the network security part, okay? Let's just go through some of these very quickly. The node security, as I said, is the most mature one. And just as Patrick has talked about, you definitely need the hardware basis. So we already put in the hardware root of trust. We already think about having the accelerator or the whole security platform. We are now seriously thinking about whether we should, a new member just came in and helped us. We're really thinking about whether we should start thinking about a common criteria approach to define our security requirement and define our own levels. I know that that's a major undertaking, but at least I think it's Frank, I think his name is Frank, he is trying to help us on that, and we at least take a serious step at it, okay? I have to say that Don Bank and Bridget, one from ARM, one from Intel, they have done a lot of work detailing the VM security part, and then based on the VM security, build the trusted computing, especially so-called the distributed T, the distributed trusted executive environment part. And those are written in our reference architecture. But they are not cast in stone yet, so we would like to have dialogue with other people. This is the part that I'm now being asked to lead, is to think about the network security. Now, network security, of course, has the more traditional communication security part. That one is the one that I say I put a stake in the ground and say that at least ask everyone to speak IP or adapt IP protocol. Because if you don't do that, I don't know how we can start our dialogue. But I've been talking to people saying that is it possible if we trying to interact some legacy system, we actually at least have kind of like a proxy that connect to the legacy system at the back end, and a front end connect to our fork node, so that it can be the proxy or can be the converter, okay? Maybe a gateway to talk to both sides. And also use that to provide interoperability with the new sensor they want to put in. I think that the difficult part here is people want to put new sensor and new actuator, even new subsystem on the whole thing without discarding the legacy system. And they also want the entire system after that being secure, and that is, that's a challenge. But at least we find out that the list of candidate protocol that we can consider to use, and they were mostly based on TLS protection of HTTP or COAP, etc. Now, the interesting part, as Jeff has suggested, we definitely have virtualization, and we definitely make our whole thing, based on SDN, the software-defined networking, and then the network function virtualization. The reason we do that is because the entire system we built on virtualization, we're running VM. We are a little bit less sure about how can we handle container, but we are committed to use VM. And because of that, we anticipate that we can actually run a lot of security services, not only for ourselves, but also for our clients, the IoT things, on our things through network function virtualization. And that's the basis that we hope we can use to build our security as a service. Security monitoring and management, we just started to think about it. Okay. The main thing, there are basically 4 bullets. I just go through the 4 bullets. The management infrastructure. Okay. We have to manage the trust. We have to manage the security policy. So basically, in the old terms, the key management and the access control management. Okay. But we know that since we are doing dynamic monitoring management, we will have different kind of policy, not only the traditional AAA policy, we also will have the management and monitoring policy. And how do we do that? We can talk. the thing that the hope, the ultimate goal is just like this morning I alleged to, we are thinking about whether we can enable behavior monitoring and then, create some kind of dynamic quasi-real-time response. And in order to do that, we have to have the closed-loop dynamics. People suggest to that. I think that has to be mainly done by research, online behavioral learning, and then also real-time response based on the online behavioral learning. But that will be the one that we hope to create the last thing that we are talking about here, is if in the future even more nasty attacks comes along, can we actually, because we have the fog, distributed fog, we can create a truly defense in-depth strategy. We can have layers and different, participate in different domains. And when we see the anomaly comes, we can take policy-based or behavior-based reaction, and then use that to hopefully make our things more survivable, and also more trustworthy. One of the things that we put on the top of our list is how to actually deliver trustworthy computing. And I hope this will just be a start of doing that, okay? The word that we use is responsive, available, survivable, and trust, so we use RAST, not only just RAS, okay? So hopefully that leaves us with some thoughts. And finally, not a politician, but still want to say that together we can make it happen. Thank you.